This question says simplify each expression. So with our log laws, we consider everything on the right-hand side of our log laws to be the simplified version when it's written as a single logarithm, and everything on the right-hand side of our log laws as an expanded form or a not simplified form. So I'll rewrite out our log laws from our formula sheet. So the left side is the simplified side. The right side is the not simplified side. So when it's written as a single logarithm, that's the left-hand side. And on the right-hand side, this is 2 logarithms subtracted. That would be an expanded side. A single logarithm is defined as a logarithm with no number out in front. So in the last example, just using the same letters that are up there, this n, when it comes out in front, the right-hand side would not be considered simplified. It would be considered expanded. So in each of these examples, it says to simplify, and sometimes questions like this will ask the same thing by asking write as a single logarithm. What you need to do is say, oh yeah, I remember when we add, we multiply. So a log plus a log fits with the right-hand side of this first equation. Notice the bases of the logs have to be the same in order for you to use the log law. You can't use the log law if it was log base 5 of 7 plus log base 3 of 8. But this one, both of those logs have the same base. Do you remember what base it is when it's not written? 10. So they both have a base of 10. So in A, we can combine it, and I don't have to write the little 10 there, log of 8 times 7, which would be 56. And so we've written it as a single logarithm. Okay, I wanted to show you something exciting. We'll finish these questions, then we'll go back to something we did yesterday, and it might explain some of the things that we saw. Cool. Okay. But B. So in B, we have 5 times log of 2. So when we're looking through these 3 formulas, I'm going to just number these. Can you see that we have the right-hand side of formula 3? We have a number in front. So that means we can put that number in front inside as an exponent. And if you wanted to, you could 2 to the 5 is 32. So this one's equal to log of 32. So that number in front, if you're multiplying a log by a number, you can put that inside of the logarithm as an exponent. And C, log of 80 minus log of 16, we have the right-hand side of the second log law. We're subtracting 2 logs. The bases are the same. So we can write that as log of 80 over 16. And 80 divided by 16 is 5. So this just simplifies to log 5. Now yesterday, do you remember when I said, okay, what's log of 3? And you typed it into your calculator, and you got 0.477. And then I said, what's log of 30? And it was 1.477. And we did another one here where I did log base 3 of 5. I'm just making up numbers. We didn't actually do that one. If I do log base 3 of 5, I got 1.46. And then I asked you, what number would you have to put in there to get 2.46? And some of you figured it out. Is anyone able to figure out what you would need to put into that second one to get 2.46? Well, and try your calculator, I guess. Sure enough, log base 3 of 15 gives us 2.46. Now, why does this work? We can explain it with our new log laws. What's the difference between 3 and 30? You just multiplied by 10, right? So would you agree that I could write log 30 is the same as log of 10 times 3? Whoop-de-doo. But now, we have a log law that says when you multiply, you add. So I could, if I wanted to, because I'm multiplying inside my log law, say this is the same as log of 10 plus log of 3. And I already know that log of 3 was 0.477. What is log of 10? Remember, logs solve for exponents. There's a little 10 here. And you're asking 10 to what power is 10? What would the exponent be? 1. And then we get 1 plus 0.477, which is 1.477. Can you see that that works with the 15 as well? Log 3 of 15 is the same as log 3 of, well, 15 is 3 times the 5. And now I'm multiplying inside, so I can write this as log 3 of 3 plus log 3 of 5. And log 3 of 5 was 1.46, and log 3 of 3 to what exponent would be 3? It's just 1. Add them up, and we get 2.46. So that pattern that you were seeing before, all of a sudden your log laws explain why that's happening in a similar way that we have our exponent laws. Okay, try questions 4 and 12 to get your first sort of working with log laws.